So welcome back to our mentor back exam explanation videos. So we're still on exam 1 from 2015 fall semester, and we're on question number 20. Sorry about the delayed upload for these videos. I was trying to upload my old ones, but apparently there's some kind of like a formatting problems appeared when I was transferring the data between my computers. So they can't really be open. I guess there's some damage happened during the I don't know, transfer process, and so I decided to make some new ones. And I don't know if you've heard about the very interesting accident that happens up on the hill, that all the raps ran out. I think just the rap bees maybe. Yeah, only the people on Brinsmade and Ben might ran out of power. So I have to get down to the library and try to make those videos. So hopefully things still work out, and I believe my computer has enough power to support me to finish my tasks. So we're on question number 20. It says the measured dipole moment of HCl is 1.11 debye, and the bond length is 127 picometers. What is the estimated percent ionic character in a HCl bond? So actually, this is one of those very classic. Actually, like all the debye problems are very classic unit conversion problems, but I don't think the instructor actually brings up this idea during the lectures. Is that debye is just a new unit, debye, DBIT, I believe. Debytes are just, oh, maybe BYT, I'm not entirely sure. Oh, it's DEBYTE, probably. Debytes. It's just a new unit we defined in order to describe the like the dipole moment of a particular bond. So it's represented by the letter mu, and it equals to the charge, like the how many electrons has been transferred, and the distance between. So this is the and the distance between the two atoms. So this is the charge, and this is the distance between atoms. And so let's take a look at this problem. And the percent ionic character is defined by the equation of I equals the mu spherical. Oh no, actually, the mu measured over the mu spherical, and times 100%. I believe both these two equations will appear on the. I believe those two equations will appear on your formula sheet during the exam. And so let's take a closer look at this problem. So it's like the measured dipole moment has been given over here. And what we need is to find what's the theoretical dipole moment between the HCl bond, the H and the Cl bond. The bond between H and Cl, probably that's the best way to describe this. So mu equals HR, QR, and Q, since there's only like H is plus and Cl minus, there's only one electron get transferred between the two atoms. So why my equation is gone? Never mind, I just write it here. QR. So and for one particular electron transferred, the charge carried by one electron is 1.602 times 10 to the negative 19, I believe. Yes, 19 coulombs. So that's the charge of one particular electron, and that's never mind. Did you see that? It just miraculously disappeared. This thing is terrible. I have no idea. I got some new equipment and I still don't really understand how should I play around with this. I think I should probably just leave my hands out, so like every time when the hands touches it, there's something. Never mind. I think there's something wrong with my pen. Never mind. Times 10 to the negative 19 coulombs times the distance, which is given. It's 127 picometers. But what we want is meters, so we have to do a unit conversion 10 to the negative 12. Maybe I'll try to find a bigger place to write this. This place is extremely small. It's not good for us. Okay, I guess like they're on a different hierarchy, so I have to use a universal. I have I have no idea, but for some reason like lately the universal eraser is so slow that I'm thinking about I probably should use OneNote in the future. This program is no longer good for us anymore. And OneNote does have some fancy pens. QR, and I just rewrote down this equation over here, and let's do it. Equals 1.602 times 10 to the negative 19 coulombs times 127 picometers times 10 to the negative 12 picometer over, no, meter over picometer. Sorry, meter over picometer. Which this gives us 2.032 times 10 to the negative 19 coulombs times meters. And all we need, so this unit is in coulombs times meters, and what we want is in debites. So we can like just set up this in order to calculate the ionic characters. It has to be like the unit must be consistent during the calculation in order for us to perform the correct calculations. And it's just a very basic unit conversion that 1 debite equals to 3.336, or maybe 3.34 is good enough, times 10 to the negative 30th coulombs times meters. So what we need is just to convert like this part, the part we just get from the last equation, into debites. So it's just mu equals 2.032 times 10 to the negative 19 divided by 1 coulomb meter. Oh, it's 1 debite, I'm sorry. 1 debite over 3.34 times 10 to the negative 30 coulomb times meters, which gives us 6.09 debites D. So we can use that in our further calculations. So let me go back and use the hierarchical. No, this is, never mind. Maybe I'll write it over here. Clear this part. It is clearable. Cool. And let's do it over here. So I equals 6. Oh no, it's 1.11, which is the measured debites over the measured dipole moment, and we need is the theoretical dipole moment, which we just calculated, 0.969 debites times 100%, which will gives you 18.2, and that's exactly the answer C over here. Okay, we'll stop here.